Today as we are looking at the sports strength lab write-up. You guys are doing this as a group together. And I'd like to walk through the rubric with you and also some specifics about how I would like your graph to be formatted to include both the serial dilution and your Gatorade sample data point. So in this lab, the objective is a little bit different from what we usually have because there is no chemical reaction going on here. One piece of feedback that I give really typically in the objective section is I say, I want you to be really specific about what kind of sports drink you're analyzing. So I want you to give me the brand, I want you to give me the flavor, and I want you to give me the volume. Because you're ultimately answering the question, how many grams of dye are in this one bottle? And that's a really specific question, very unique from the groups that had the littler bottles of Gatorade versus the ones who had bigger ones. So I want you to be as specific as possible when you're describing what kind of sample you're looking at. Also, in terms of the methods here, we are looking at Beer's law and colorimetry or spectrophotometry. So that implies that you're going to present the equation either in the objective or in the background for Beer's law. You're also briefly describing serial dilutions, and you're making mention of graphical analysis for your data. So normally we would say things like we ran this chemical reaction, we collected this precipitate value, and then we did stoichiometry to get to our goal. For us in this, we're doing spectrophotometry, serial dilutions, graphical analysis to be able to answer our question. So you won't see a chemical reaction equation in our objective, which is a bit unique from what our typical situation is. Remember, the background section is this opportunity for you to develop the different vocabulary words so that when you get to your discussion section, you've already defined all of those words and now you can use them to tell the story. So the background should set up all the pieces so that your discussion can walk through every step of the lab and say, why did this step get me closer to my goal? So in the background for this, we're looking at Beer's law. So you're describing how does light interact with dye? Why is it that in a colorless solution, we say that all light is allowed to pass through? Whereas if you have a solution that is colored, why is it that the light is being inhibited from coming through? And then how does Beer's law allow us to actually make measurement then of the concentration of that dye? So you're defining things like spectrophotometry as a lab setup. You're defining Beer's law and the equation and what those different vocabulary words mean. We're looking at serial dilutions. What is that as a construct? And really developing here, how do dyes interact with light? And then in terms of your calculations, the calculations on this are really brief. All you're doing is you're going to present Beer's law, and then you're presenting one calculation that says, okay, here was our, actually, I suppose there's two, so sorry. One, you're going to have a dilution equation to show how you took your stock and created your serial dilutions. You don't need to give me more than one of those because I'm assuming you'll have done the rest. And then your one calculation for this lab really is to say, here was our absorbance value for our Gatorade, and then what does its concentration end up becoming based on the equation that you got for your line of best fit. So calculations, it's a dilution equation, and it's using your line of best fit to go from absorbance of Gatorade to concentration of Gatorade. Molar absorptivity percent error calculation. So I will come back to that in a moment. Let's go on to the graph. So the graph, we worked with actually putting this into Excel already so that you could get your line of best fit. I'd like to show you a couple of details about a graph that I think are really important in terms of the formatting. So going over here, this is a set of data that I have constructed, say for blue 1 as a dye. So right now, this particular graph, if I were to click on a data point, it should show that the data points relevant to this lab are columns A and column D. So concentration on the x-axis, absorbance on the y-axis. Please remember that I need you to have your axes labeled and have units in them. So if you don't have that labeled, what you can do is you can go up to Chart Tools and you can say Add Chart Element, and it'll drop down a series of options. So you can say, what's my title? I want you to also have a chart title. Um, if you have lots and lots of space where your data points are, represent this much of your graph, and then you've still got all this space afterwards, you can go to grid lines and you can tighten up how many grids or how far that axis goes. Um, you can also add more grid lines if that's kind of visually helpful to you. So I want this graph to be as tight as possible around your data points. In this case, this is good. There's not a lot of additional space either on the x-axis or the y-axis. And then I've also added my titles with units. And remember, absorbance does not have a unit. Then I also have up here my equation. Now you could actually change this to A and C to actually represent absorbance and concentration. I think that would be a nice thing to do. And then you also have your confidence level. So R squared value is represented there. That should be represented in a white space of the graph, not on the graph lines, so that it's easy to read. Now what I'd like to do is I'd actually like to add my Gatorade data sample immediately onto this graph. Now I can't just put it into columns A and D because then it's actually going to start to try and put it into this line of best fit. And I would actually like it to just be a second series in the data table itself. So what I'm going to do is I'm going to click on the graph and I'm going to say select data. So I've clicked on the graph and then I right click it and I say select data, and you're going to have a chart listed here. So notice you already have absorbance listed as one piece. And now what I'm going to do is I'm going to hit the add button. Okay. And I'm going to give it a name. I'm going to call it my Gatorade sample. And then to select the values for X and Y, I'm just going to select the one number that I have for my Gatorade sample. So I'm going to just click on that value that I put in for my Gatorade. And then for my Y, I will do the same. And you'll notice my Gatorade comes up as an orange point. I still have to put the Y value in, so I'm just going to say equals, and I'm going to click that number as well. And then I'm going to press OK. And OK. And so the nice thing here is that it allows me to put an additional data point on here without interrupting this line of best fit, and it prints it in a different color. I have calculated this absorbance value from my concentration, I've calculated the concentration from my absorbance value using this equation, and now I've taken these two data points and inserted it directly onto this graph so that I only have to put one graph into my actual lab report. It might be helpful to actually take that data point and add a title to that one so that you are able to actually show which one is which. Okay, so you could add a key if you want to be able to indicate the difference. So again, graphs should fill up the whole chart space, or we should tighten up that chart space there to show that. Please label the axes with units, and then make sure that your equation is showing you have a title that's descriptive, and then we also have your Gatorade data point there. For our results, there is no value that I've given you for the dye to compare your answer to, so you're just telling us what you got. And then for your discussion, how does taking a Gatorade sample and a stock solution, how does taking a stock solution diluting it a bunch of times, putting it into your colorimeter. How does that tell you grams of dye in a sample of Blue, Freeze, Cool Breeze, whatever Gatorade? Like, how does taking this random bottle and adding water to it and putting it into a colorimeter answer that question? This is really what I want you to be able to get at in your claim evidence and reasoning. You'll notice I haven't put an error analysis into this report. I'd like you to just calculate your molar absorptivity value and compare it as a percent error to say not so much how close were we to the expected value, but the molar absorptivity, what that allows us to look at is it just allows us to look at how well is this colorimeter really getting us um, along the path to our answer. So by calculating the molar absorptivity, what you're doing is you're doing some analysis on the strength of the instrument and how maybe precise it's going to allow us to be when it to come to our answer. So again, molar absorptivity is going to be the slope of your line. So if I went back here, my molar absorptivity value is going to be that slope of 3.8776. That's your molar absorptivity and your path length. And so if your path length is only 1 centimeter, then you can find out your molar absorptivity using that slope value. One thing to remember is that this is in micromolar, and your molar absorptivity that's given to you in the background section of your lab handout, those molar absorptivity values are given to you in molarity. So you're going to have to make sure that you convert your slope value to actually be on the same order of magnitude as these molar absorptivity values. I said before that you only have a couple calculations. It's occurring to me that as I'm talking about finding the answer of dye, that you actually have one more to go. So in your calculation section, you've got your dilution equation to show the serial dilutions as part of the setup for the lab. You also have your stoichiometry. Of course, we always do stoichiometry to go from volume of Gatorade bottle to moles of Gatorade bottle using your molarity value from Beer's law. And then once you've got moles of Gatorade, using the molar mass value for your dye to actually come to amount of dye in your particular bottle. So your particular bottle has some volume measurement on it that you needed to grab in order to be able to go from volume to moles to grams of dye. So again, in this lab, I want you to be thinking about how does colorimetry or Beer's law help us go from intensity of color to amount of material. That's the story that I want you to tell here. And so as you come back to the end of this discussion, I want you to be rooting in or explaining how does each step of this lab get us to that answer. And then please always make sure that you're routing back to the original goal. So what was the goal of this lab? Trying to determine the number of grams of what dye in what Gatorade sample, and then what is the answer that you came up with. I hope this helps. Email me or come chat if you have questions.